You ever wonder how a tiny website, maybe built by one person in their bedroom, suddenly handles a flood of traffic like you'd see during a Super Bowl ad? Well, it's definitely not magic. It's all about smart, step-by-step system design. All right, let's dive in and see how it's done.
So yeah, this is the big question, right? It's really a journey. You start with something super simple, and you end up with a complex system that can serve people all over the planet without even breaking a sweat. We're going to build that system together, right here, one piece at a time. You know, almost every great website begins right here, just one server doing absolutely everything. The web application, the database, it's all just humming along in one happy little box. And this is great. It's simple, it's cheap, and it works perfectly for a while.
And then you get the best problem you can possibly have. You get popular. Your site is a hit, people are pouring in, and that one little server, it just can't keep up. It gets totally overwhelmed and starts to crash. This is that moment every engineer kind of dreams of and also completely dreads. Okay, so what's the first move? Well, we need to bring in a traffic cop. And that's pretty much exactly what a load balancer is. Instead of letting all that traffic slam into one server, the load balancer sits out front and smartly directs all the incoming requests to a whole team of servers. And this shows the new setup perfectly. See? We've stopped trying to make one server stronger, and instead, we're just adding more servers to the team. Now we don't have just one web app server, we have 3, or we could have 10 or even 100. The load balancer takes care of spreading out the work so no single server gets buried. We've just solved our first major bottleneck by what's called scaling horizontally. Now, the really cool part is how the load balancer actually decides where to send all that traffic. It's not just random. It uses clever algorithms. The most basic one is called round robin. It just goes down the line, one server after the other, but it can be way smarter. It could send traffic to the server that has the least connections at that moment, or it could even keep an eye on which server has the fastest response time and prioritize that one. It's all about picking the right strategy for the job. Okay, so our web servers are breathing easy now, but we've just created our next problem. All of our shiny new web servers are now all trying to talk to our one single database at the exact same time. We've basically fixed one traffic jam, only to cause a new one right down the street. And yup, there it is. The database is now our single point of failure. It is just struggling to keep up with all the requests for data coming from our army of web servers. Remember, a system is only as fast as its slowest part, and right now, that's definitely our database. So, how in the world do you scale a database? The answer is replication. It's a simple but powerful idea. Instead of just one database, we create copies of it. This lets us split up the workload, especially all those read requests, which are usually the thing happening most often. Let's take a look at how this works. We now have what we call a primary database. Its only job is to handle all the writes, like when a new user signs up. Then that primary database immediately replicates or copies that new data over to multiple replica databases. And these are our read replicas. This breaks it down perfectly. So, step 1, a write comes in, it only goes to the primary database. Step 2, the primary immediately sends a copy of that new data to all the replicas. And then step 3, whenever our web servers need to read data, like loading a profile page, they can just ask any of those replicas, spreading the load out. It's brilliant. So our system is way more resilient to traffic now. It can handle a lot more users. But we're not quite done. Even with all these read replicas, going to a database to get the same popular information over and over again is still, well, kind of slow. We've scaled our capacity, but now we need to optimize for pure, raw speed. And that brings us to the cache. The easiest way to think about a cache is like the system's lightning-fast short-term memory. It's a special layer of super high-speed storage that keeps a copy of the most frequently used data right where the application can grab it in an instant. And look where it goes in our diagram. The cache sits right between our web apps and our database. And here's why it's so fast. Caches usually store data in memory, in RAM, instead of on slower disk drives like a database. So now, when a web server needs some data, it checks the cache first. If it's there, boom, it gets an answer in microseconds and never has to bother the database at all. This right here is the secret sauce. It's a principle called locality of reference. That's just a fancy way of saying something really simple. If you just looked something up, it's pretty likely that you or someone else is going to look for that same thing again very soon. Caching just takes advantage of this totally predictable pattern. Now, here's a quick pro tip. Not all caches are created equal. Two of the biggest names you'll hear are Memcached and Redis. As you can see, Memcached is famous for being incredibly simple and fast. Redis, on the other hand, is a bit more of a Swiss Army knife. It's super powerful because it supports more complex data structures. Which one you pick really just depends on the specific job you need it to do.
And here it is, the whole shebang. Just look at how far we've come. We started with one single server, and now we have this beautiful, scalable system. We've got a load balancer playing traffic cop, a whole fleet of web servers to handle requests, a super fast cache layer for speed, and a replicated database for reliability. This architecture right here, it can handle millions of users, no problem. So what's the big lesson in all of this? Well, it's that scaling isn't one giant, complicated leap. It's a journey. You always start simple. Then, when things start to creak under the load, you find the exact bottleneck, and then you bring in a specific solution, like a load balancer or database replicas or a cache that solves that one problem before you move on to find the next one.
Okay, so we've built an incredible system. It can serve a massive audience in, say, North America. But what if your users are in Tokyo and London and Sao Paulo? How do you make sure the experience is fast for all of them? Well, that gets into things like content delivery networks and multi-region architectures. But that is a much, much bigger story for another time.